Okay, welcome back to section 11.6. I want to talk about a couple of key features of parabolas, the vertex and axis of symmetry. So the vertex is the point where it kind of changes from going down to going up again. Some of your parabolas open up, in which case the vertex will be that very bottom point. Some of your parabolas are going to open down. They're going to be kind of upside down U's, and the vertex will be the very top point. It's either the bottom of a valley or the top of a hill. And you can see that in the picture in blue is the vertex point. The axis of symmetry, we talked on, especially when we were doing those table values, about the symmetry there, kind of between those x values on either side. And you can see it visually. Like we could fold our paper in half and it would be a perfect mirror image, okay? And so that axis of symmetry, it's always a vertical line for these parabolas. And it goes through the vertex, okay? So your vertex, if you have it written in the format of f of x equals some number times x minus h squared plus k, that h and k will tell you exactly where the vertex point is. So hk is the vertex point. Now keep in mind that it's x minus h, so it's going to be like the opposite of what you see in there. Okay, so it's like if it's x plus 1, you're really looking at a negative 1. If it's x minus 1, you're looking at a positive 1. So it looks kind of opposite. The axis of symmetry is always the line, so it's a vertical line, so it's x equals a number, and it's always going to equal that h value. It's always going to equal the x coordinate from your vertex. Okay, that's where the axis of symmetry is. We also talked briefly last video about that a value. If your a value is positive, you're going to open up. If your a value is negative, it's going to open down. If your a value, if the magnitude is bigger than 1, it's a pretty narrow looking graph. And if that a value is, the magnitude is less than 1, so between 0 and 1, then it's a wider graph. Okay, so we can use a lot of that information to graph these a little more effectively than just making a table of values every time. Okay, so what I want us to do in example 4 is we're going to graph our function. We're going to identify our vertex. We're going to identify the axis of symmetry. And then, just for good practice, we're also going to give the domain and range of the function. So the first one I have in example 4 is f of x equals x minus 2 squared plus 3. That a value is 1, so it's going to have the same shape as the x squared graph. With the x minus 2, there's your h, and the plus 3 at the end, there's your k. We can go ahead and identify our vertex right away. We don't even need to graph it or need to do a table of values. The x coordinate of our vertex is positive 2. It's always kind of the opposite of what you see in there. It's a minus 2, which means that positive 2 is our x value, and then that plus 3 means that we have a y value of 3. Okay? The axis of symmetry is always a vertical line, so x equals a number. And it's always going to equal the x coordinate from our vertex. So if the x coordinate is 2, the line x equals 2 will be our axis of symmetry. Okay? So when I'm plotting this, I can definitely start with that 2, 3 point. There's our vertex. I can tell you with the a value of 1 that it's going to open up. Personally, what I like to do is I like to think about that normal x squared graph, kind of the f of x equals x squared graph, and I know some of those points, okay? And I just kind of have some easy squares memorized. You know, the negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And then I take those points, and what I do is I'm going to go right 2, and I'm going to go up 3. And I can graph much faster that way than making a new table of values, because I just take these points. I'm like, well, instead of 0, 0, right 2 and up 3, there's my new vertex. Instead of 1, 1, I'm going to go right 2 and up 3, there's my new point. And instead of negative 1, 1, I'm going to go right 2 and up 3. All right, instead of 2, 4, I'm going to go right 2 and up 3. Instead of negative 2, 4, I'm going to go right 2 and up 3. Just like that. And then that helps me to graph it very quickly. And this is called transformations, in case you're curious. So that's one way to graph it. You certainly could just make a table of values and say, well, my vertex is at 2, 3. So 2 should be my middle value when making a table of values. You could say here's 2, and I should probably do, 1 or 2 before and a couple of them after. Okay, it's because I know that 2 is the middle value. All right, so here is our graph, and you'll get exactly the same points as what I just did with transformations. All right, now that we have it graphed, so here's our vertex, here's our axis of symmetry, we can answer the other part of the question, which was, well, while we're at it, let's go ahead and do domain and range, okay? So the domain for this function, well, it keeps going to the right for forever, keeps going to the left forever, and to the right forever. Our domain is all real numbers. It's negative infinity to infinity. For our range, we have a bottom value. Our least y value is 3. And then it keeps going up for forever, which would be an infinity. It includes the 3. There's a point there. So we'll have a bracket at 3. And we always use parentheses with infinities because you can never quite reach them. All right, let's do another one. So we're going to graph another function. We'll identify our vertex. We're going to identify that axis of symmetry. And while we're at it, we'll get the domain and range of that function. Okay? So this new one, we have h of x equals negative 1/3 x squared plus 3. So first off, let's go ahead and do our vertex. If you notice, it's just a regular x squared. We don't have like parentheses with any other numbers in there. So that tells me that my x coordinate is 0. It's like x minus 0 squared. And then the y coordinate comes from right here. The plus 3 means we have a y coordinate of 3. The axis of symmetry would be an x equals equation because it's a vertical line. And it's always x equals the x coordinate from our vertex, so x equals 0. There's your axis of symmetry. Okay? We can actually answer the domain and range right now if you really wanted to. Because that a value is negative, I know it's going to be a downward shaping u. So if you want to go ahead and answer that beforehand, you can. Anything can be squared. We know that that domain is going to be negative infinity to infinity. For the range, what's going to happen is it's going to go down for forever, so that's negative infinity. And then it's going to stop at the vertex point, which we know is the point 0, 3. For range, you're looking at y values. The y value is 3. So that point 0, 3 is your maximum. And so the largest y value we'll have is the positive 3 that we see in the vertex. Parenthesis for the negative infinity and a bracket for our 3. So we can actually answer that without even graphing it, which is pretty cool. But since we are going to graph it, let's go for it, okay? Let's see, our vertex is the point 0, 3. And we got this nice little axis of symmetry of x equals 0. We'll try it with a table of values. I think that might be easier for some of you. So when I'm doing my table of values, I know my x value of 0 is kind of my middle point. So I'm going to put that in the middle of my table. And I'm going to do some before and some after. Now, I'm kind of looking ahead here. I'm about to do a negative 1/3 times that x squared. So I think the easier points to graph are probably going to be factor or multiples of 3. So how about we do like a negative 3 and a positive 3? I think that would be kind of nice. And then we could even do like a negative 6 and a positive 6 if you want some extra points. Okay? So if I have negative 6 squared, well, that would be 36. And then negative 1/3 times 36, that's the same thing as 36 divided by negative 3, which would be, goodness, negative 12. And so then I have negative 12 plus 3, which would get me to negative 9. Okay. At negative 3 squared is positive 9. And positive 9 times negative 1/3, or positive 9 divided by negative 3, if you want to think of it that way, would give you negative 3. And negative 3 plus 3 is 0. We already know that the point 0 is 0, 3, but if you want to double check, 0 squared is 0, times the negative 1/3 is still 0, and plus 3 would be 3. And we can probably know what the other two are. If you want to double check, you're welcome to double check. But I also know that there's the symmetry that goes through that axis of symmetry here at 0. So if at -3 we have a y value at 0, at +3 we're going to have the same y value. If at -6 we go to -9, at +6 we're going to do the same thing because of the symmetry here. So you can save yourself a little bit of work that way. So let's plot our points. We've got -6, -9. We've got -3, 0, 0, 3, which we already had. +3, 0, and 6, -9. So you can see our nice U shape here. You'll notice that it's downward, just like we thought it would, because of that -a value. You'll notice it's also a wider graph than normal because of that 1/3 instead of just a regular x squared. Now it's your all's turn. You get to try one and show me how much you've learned.